Okay, everyone, welcome to the Green Tech and Sustainability Pitch Night. I hope you can hear me well. Welcome. My name is Mathilde Vade. I'm your host tonight, and happy to have you all with us for this evening. I will share my contact details in the chat, and you can do the same if you want to start networking. You can leave your LinkedIn, for example, and the name of your company. I will be sharing also the schedule and the link to the pitch decks of the 5 companies that we will discover tonight. And you can use the general chat or private messages to ask questions to the presenters and to interact with the other attendees. Shortly about the Startup Club, we are a one-stop shop for the global entrepreneur community. Our vision is to assist businesses in their funding rounds and in their growth journey by connecting entrepreneurs with investors, advisors, and mentors in the startup ecosystem internationally. And we do this through a series of pitch nights and investor networking conferences. Currently, we host pitch events in different industries. We have health tech events, green tech, fashion, beauty, and luxury, SaaS and marketplaces, hospitality and lifestyle pitch nights, and also real estate, and also an AI startup competition. I will share in the second half of the event some free tickets to these events if you're interested to join. So as I said, tonight we will have 5 companies within green tech and sustainability. We are very happy to welcome you all this evening. So tonight we will hear as a first presenter Hiera, a sustainable American-made activated carbon, providing modular solutions to transform agriculture waste into high-value sustainable products. The Hiera is represented by David Topolewski from the USA. Second pitch of the evening is Loop Chemicals, decentralized low-carbon ammonia production for agriculture, closing the loop between renewable energy and fertilizer, presented by Doble, also from the USA. The third company is Mountain Renewable Energy, delivering long-duration hydrogen-centric energy storage through an affordable energy-as-a-service model. This company is represented by Derek Roy, also USA. Fourth of the presenter of the evening is called Flag Turbines, flexible, scalable, vertical axis wind turbines that meet diverse energy needs, delivering sustainable solutions for communities and businesses, presented by Maarten van Oeveren from the Netherlands. And the fifth is called Enviro Farm, leading the way in land regeneration, climate adaptation, and sustainability management, presented by Michael. Yes. And we have with us 5 advisors tonight. We have David Murray Hondley from Pario Ventures. We have Laura Lopez from Cleantech Nexus, Claudio Colombo from Next Step, Ellen Tibieros from We Grow Green Tech, Anne-Marie Christoffersen Deb from Unconventional Ventures. So, maybe we can do a short presentation of all the advisors. Maybe David, would you like to start by introducing yourself? I think he's not here yet. So let's start with Laura.
Hi, good evening, everyone. Thank you very much, the Startup Club, for this opportunity. We are Cleantech Nexus, and what we have is the connection. We deal with all cleantech stakeholders, from startup to experts, mentors, and government connections also. So the services is 2 lines. We support them from coaching, by connecting with investors, by all the pilot testing atmosphere, and the EU funding. We can also support from end-to-end services on the writing and in Horizon Europe, Innovation Fund, ESC, and all that support. So I'm very much looking forward to hear your pitches, and I'm hoping to give you the best feedback I can.
Thank you so much, Laura. It's a pleasure to have you with us again. Let's ask now to Claudio for an introduction.
Hi, so thank you for inviting me. I'm a general partner of Next Step. We are a climate VC, venture capital. We are part of Next Energy Group. We are one of the largest investors in solar energy in Europe. With the VC arm, we invest in anything that can support the environment. So, like to see all the pitches.
Thank you so much and welcome, Claudio. And now let's ask Anne-Marie for an introduction. Anne-Marie?
Hi
Cannot
there,
hear you.
everyone. My apologies
Hi.
for the delay. I'm just logging in from Mashup in Malmö, but I'm representing Unconventional Ventures this evening as head of investments. We're a fund to generalist fund focused on underinvested founders with a focus on impact solutions, generally within the areas of climate and healthcare and resilient infrastructure. So very excited to sort of hear the pitches this evening and being able to sort of like hear how you're growing overall. So thank you very much for the invite to be here this evening.
Thank you so much, Anne-Marie, for the introduction. Great to have you. And we have also Hélène with us. Hélène, would you like to introduce yourself?
Yes, sure. Good morning, everyone. Nice to be back to the event. So We Grow Green Tech is a boutique consulting firm. We have decades of expertise in energy, sustainability, and decarbonization. We work with very selected technology to accelerate the entry to specific geography, but also through the introduction of new market. So I'm very thrilled to be here today. Always very excited to look at new innovations. Thanks for the invitation.
Thank you so much, Hélène. We will now move to the second presenter to keep the schedule, which is Loop Chemicals, presented by Dan.
Hello, everyone.
Hi.
All right. Screen sharing okay there?
Yeah, good.
Fantastic. Well, thank you very much for the introduction there, Mathilde, and a pleasure to talk with everyone today. So I'm presenting on Loop Chemicals, and we are a manufacturer of clean distributed ammonia. So nitrogen is an essential element for all life on Earth, and the nitrogen in the food we eat comes primarily from ammonia. So you see here a chart of the market for ammonia. It's a multi-$100 billion market, and it's set to increase in the future at a faster rate than GDP. Now, in the future, there's also going to be another market for ammonia, and that is as a fuel, either directly or as a carrier for hydrogen fuel, also for energy storage and backup, particularly long-term for data centers. Now, there's a few problems with the current ammonia industry, which I wanted to highlight here. The first is the incumbent ammonia industry is responsible for about 2% of the world's greenhouse gas emissions. That's in the manufacturing, which we're addressing. There's also, by the way, another 3% in field emissions in the form of N2O. A second problem I wanted to highlight is, so ammonia is incredibly cheap to produce, right? I mean, we're talking just a small hundreds of dollars per ton figure. So proportionally, the transportation cost can be very high. It's made in fossil fuel regions, transported to agricultural regions. On average, that transportation cost represents 35% of the retail cost. And in some places like inland Africa, the North Dakota, the Canadian Great Plains, it can actually be half the cost or more. A third problem, particularly pertinent at these current times, is geopolitics, right? So about 30% of the world's nitrogen fertilizer is currently stuck behind the Strait of Hormuz and unable to get out. This has resulted in a spike in fertilizer prices. And actually, the same thing happened back in 2022 with the outbreak of the Ukraine war. So the current distribution model is very susceptible to these price spikes. Okay. So we have a solution to these three problems, and conceptually very simple. So we're moving away from the current large plants, which are typically above 1 million tons per year each, very carbon intensive and located often thousands of miles from the farms they serve. We're instead envisioning a future where we have small decentralized plants. They serve farms in a 50-mile radius. They'd basically be co-located with agricultural retailers, and we'd be using renewable feedstocks and energy sources. Okay, so conceptually quite simple. Technically, so why hasn't it been done before, right? So there's a number of challenges. Perhaps the most prominent one is ammonia is currently made via the Haber-Bosch process. Okay, this is an equilibrium reaction. Thermodynamically, you benefit from high pressure. When you have high pressure, it means you require very powerful compressors, very thick reactor walls. Bottom line is this, you can downsize it, but not economically. Okay, the prices per ton of ammonia go up significantly at lower size. So this is where we come in. We have licensed technology from Sandia National Labs in the US, and it was produced in combination with Sandia and ASU. And it's a chemical looping process. So think of it this way. You have what is called a carrier material, and your nitrogen is absorbed into the carrier material. And then in the second step, you introduce hydrogen, and the hydrogen then reacts with the nitrogen and released as ammonia. In the process, you're regenerating the carrier material, and it goes around for a second loop and a third loop and so on. So that's our technology solution. We're now getting away from the equilibrium reaction, and it means that you can successfully operate at much lower pressures. Sandia have operated at 20 bar pressure, 1/10 the pressure, and it becomes more economical at small scale. So where are we right now? I want to be completely honest with you. This is an early stage technology. We are at TRL 3. These are some parameters which were measured in the lab at Sandia. So we demonstrated ammonia production at 1/10 the pressure. We've actually got higher conversion than you get from Haber-Bosch. Making a techno-economic analysis using the laboratory measured parameters, we're actually getting a slightly higher price than incumbent Haber-Bosch, but we do think there's potential to reduce this down to a fraction of the price. And this is really going to be the focus of the next 1.5 years. We're focused on increasing the kinetics. We also want to demonstrate the longevity of a carrier material over 1 month performance. After that, it's going to be more a case of scaling up, focusing first on the thermal integration. And then ultimately, we do actually have a letter of interest from a bioethanol facility in North Dakota. Basically, we're looking at using fermentation residues, converting them through anaerobic digester, first to biomethane, then hydrogen, then ammonia, which will go back and supply the surrounding farms. This would actually generate 45Z credits in the US as well, which would help subsidize the whole operation. From a competitive perspective, when you look at other ammonia manufacturing technologies out there, and there's several of them, ammonia is a commodity, right? The most important things are cost, of course, carbon emissions increasingly, and the ability to manufacture on small scale for our envisaged market. So we're the only approach which combines these three things. I'm sorry. Okay, so actually there's fascinating papers which are out there written and review articles. So the transition from centralized to distributed nitrogen fertilizer manufacturing is happening, okay? There's companies out there right now which are doing downsized Haber-Bosch. They make most economic sense currently where there's either high subsidies or where the transportation costs are especially high, but it is already happening. We're right at the start of the adoption curve. And in my mind, there's no question at all that it will happen in the next couple of decades. And as I say, people have written papers about this. Our technology, we believe, is 4 years away from market. So we will be both a technology developer and a project developer. We're going to, first of all, go to market using downsized Haber-Bosch, which we'll say will only be economically viable at the most certain sites where ammonia is already very expensive and where there's subsidy. Meanwhile, we'll be developing the chemical looping process and coming at a much lower price point. So here's an idea of a market size. I mean, this is USA specifically. If we can manufacture ammonia at $900 per metric ton, which we believe can be done with downsized Haber-Bosch using technology from European EPCs, there's a $2 billion market there right away, and some competitors are already addressing this market. Chemical looping, we believe we can get down to $600 per ton or less. This opens up a $20 billion market. That's just in the USA. So, okay, team. I'd like to think we have a very experienced team. I was most recently in SABIC Agri-Nutrients, along with my colleague Joe here. We supply about 5% of the world's ammonia, so we do know the market very well. Joe's also a family farmer on the side. We have co-workers Jonah and also Chris. We have a fantastic team of advisors. So Andrea is at Sandia National Labs. We have weekly calls with her. Dan is our bioethanol businessman in North Dakota. And Kevin is a lifelong colleague, very much active in the Boston area ecosystem where I am based. So that's really it. In summary, I think we do have, a really large market here. And I think in this time, especially, a very compelling market case. We do have a differentiated technology. And we have an experienced team. And, we're optimistic we can be successful. And we're going to make a huge impact, not just economically, but also environmentally. So thank you, everyone.
Thank you so much, Dan. Thank you. Let's go right into the Q&A, and let's start now with Claudio.
Thank you. So thank you for the presentation. So you said you are now at TRL 3. Can you walk me through the journey from here to a commercial plan in capital terms? So understanding how much money you will need at every stage and milestone that this capital will unlock.
Yeah. So we do have a more detailed pitch deck which covers this exact topic, but for now, just to go over, sorry, I've skipped past it, to go over the slide which covered this on a high level. This was the one, yeah. Okay, so it's currently laboratory-based technology. That's a definition of TRL3, basically, okay? We're getting some very good performance measurements. We're delighted. However, we do think to get the necessary economics to be competitive at that $6 per metric ton, we need to do a couple of things. We either need to have a lower cost carrier material, or we need to increase the kinetics, so we need less carrier material. Either one of the two is fine. Okay, so how to do this? We've got a number of technical approaches, and at this point they're theoretical, right? I mean, we need to test them out in the lab. The material-based approaches will be done by Sandia. Okay, they have all the necessary laboratories, equipment to do this. Within Loop Chemicals, we're focused on reactor design. We have a number of concepts where we think we can increase the kinetics through design features in reactor. We're going to be, for example, minimizing the path length of reactor, maximizing the surface area. This will enable us to increase temperature and enable faster reaction. This is what we're describing as phase 1. And sorry, the other thing in phase 1, we're going to be, so far we've done a relatively modest number of cycles. It's less than 20 cycles. Excellent repeatability in those 20 cycles, but obviously we need to do thousands. So we will also explore this in phase 1. This will take 18 months. We're budgeting at about $3 million to be split between us and Sandia National Labs. Okay, we're looking to raise about half of this from the US government. I mean, one of the things of working with a government lab, right, we can access some funding through them. And the other half is why I'm talking to you today. We're looking for individual private investors. So that's phase 1. Phase 2 will follow up after that. And at this point, we'll have demonstrated the necessary reaction performance, but we're really focused on scaling up. So this includes thermal integration and just, scaling up an order of magnitude step by step. We believe this will take 2 years. Budget-wise, we haven't, this is, fairly early stage in planning, but for sure, it's going to cost more millions of dollars. We do believe single-figure millions of dollars, however. And again, we do hope to access government funding there. The actual plant, the first plant, which would be from North Dakota, we're looking at a time frame of about 4 years. This will have a scale of 15,000 tons per year, and it will have a capex cost of $20 million.
Thank you. And if I can, You have patents, so how is protected at the moment the idea, the technology?
So the IP currently is licensed from Sandia. They have 3 patents and 1 patent application. We are currently at this time within Loop Chemicals working on advanced reactor design concepts, and we are filing provisional patent applications, as we speak, basically.
Thank you.
Thank you, Claudio. And Laura, would you like to go next?
Yes, thank you. So thank you, Dan, for the presentation. And to be honest, I had a little bit similar question like Claudio, because I mean, the background expertise is the clean tech, and we see so many clean new technologies that they like to compete in cost as you because it's more locally and then so on. But at level TR3, three is a little bit, let's say we have the hopes, the ambition, we have the tools. You say you have a letter of interest already, and it's on the lab, right? So then we need to be very careful on all the steps to take consideration. For instance, just to be out brainstorming here, what about like the intention of the farmers and the distributors? Do you go around? Do you see a will in there to shift from the current supply chains, because it's a big change. I mean, it's very well done, the intention, but there's many little points you have to consider that it doesn't fail.
Yeah, okay. It's great series of questions, Laura. And these are kind of things which we wrestle with all the time, of course. I share with you my own personal perspective, what I'm thinking. So, by the way, my background is, so I was in SABIC for 14 years. SABIC, we're a very large petrochemical company. I was actually in the venturing team, strategic venturing team, for 8 years, actually. So I've seen things from the other side of the table. And I'm kind of used to doing due diligence on companies, right? So, I'm seeing things from the other side now. Anyway, my humble opinion, for what it's worth, is the market case is actually extremely strong. I think in my opinion, we've got relatively low risk there. We've been talking with agricultural retailers, we've been talking with bioethanol producers, and if we can make ammonia at sufficiently low cost, they do want to have this co-located locally. There's very strong demand here. And I mean, in my mind, there's no question whether this market is going to exist or not. It really will. It really comes to a question of, can you make the ammonia low enough cost, or can there be other incentives which make it overall economically viable, subsidies and so on. Okay, so then, you did ask initially about the technology as well. Well, I mean, I'll be honest. I'm from a technology background myself. I was most recently chief scientist in SABIC Agri-Nutrients for the last 3 years. I mean, this is our biggest risk point, right? I mean, we are TRL3 by definition. We've got some ways to go. I mean, we've got 4 years to go as well. So, we're already talking to the market, but we still got 4 years of development ahead of us. So, there's a gap there we need to fill. I mean, I do think one thing which is a strength for us, which is differentiating us perhaps from a lot of other early stage technology startups, is we are looking to go to market initially as a project developer using existing technologies, right? So, we're not going to wait for those 4 years. We're going to bring along this technology in parallel, but we're going to be going to market like right away using downsized Haber-Bosch. You can license this technology from European EPCs. It's nowhere near as cheap as chemical looping that we're working on, but there is a market there still. There's a small number of project developers out there which are commissioning projects, and we want to be one of them in the near term. So, it's kind of an interesting approach. We're both a project developer and a technology developer, but actually I think the two things complement each other very well, right? If you're developing things in technology in isolation, right, and you're not really working in the market, that's a big risk. You don't really know what the market is.
Yeah, that's a good point.
On the other hand, if you're a project developer, right, it's very hard to differentiate yourselves. I mean, you want some kind of differentiated technology which will get you that lower price point and separate you from other developers. So anyway, wrestled with exactly your questions a lot, and this is my answer. This is where we've come out at the end.
Okay, thank you, Dan. Good, the best luck.
Thank you. Great.
Thank you so much, Laura. We have time for one more feedback, and let's ask Hélène for her questions. Hélène? I cannot hear. We cannot hear you. Hélène?
Could you hear me?
Yes, now.
Okay,
Yes.
let's zoom this morning. So Dan, congratulations. I actually start studying this space with some of the gentlemen in my team. I think ammonia is going to have great opportunity. That's a little under the radar since, but I think, for example, I work with India, the scenarios, it's starting to look very carefully. I don't have many questions. I think your approach is very stage gate. I think you're looking at things from a very practical but also innovatory approach. I would tend to think that I will probably, just because I'm starting to see more and more heat in that space, your approach is very practical and conservative, which I love. I would probably start looking for strategic partner. I mean, you mentioned phase 3. That's where you really start approaching. I would probably start approaching a little earlier because I think the space is starting to move pretty well. So, but no, congratulations. I think it's a very interesting space. And you obviously have a very strong team. So I look forward to seeing your progress.
Yeah, thank you. Appreciate that. And so so one of the benefits we have, so myself previously being in SABIC Ventures for 8 years, right? So I know a lot of the strategic investors, right? So, went to events with them, you get to know them really well, you complain about your company you work for, all this kind of stuff. So I know them very well. I don't know the early stage investors, you guys so well, so hence, I'm doing events like this. But anyway, talking strategics, right? So I know CHS, the biggest agricultural retailer in the US, very well. I know Corteva, I know ADM, so I've been in contact with the venturing teams. Yeah, I mean, there is very strong interest for sure. They're looking at, they do want what we have. I mean, there's really no question in my mind. Going back to a previous question, I mean, one of the challenges we have is we have a TRL3 technology, which is going to be 4 years out. So, that's why we're looking at bringing along a pipeline of technologies sooner than that. And, including just the incumbent Haber-Bosch downsize, which turns out you can get from European EPCs primarily. So, yeah,
But
there's strong demand. Yeah.
if you open, I've been recently, you can look at my website and so some of the things we posted on LinkedIn, we've been starting to work closely with India. This is a very interesting dynamic right now. A lot of people are concerned because it's hard to navigate, but if you position it well, there are interesting opportunity. If you look, for example, the amount of early stage investor in clean tech has been increasing tremendously. The amount of funding that they're dedicating. And what's interesting is they're looking into, if you open to the concept of a joint venture, right, and starting to license the technology, which you could put the manufacturing in India, and then from there, I think there could be a great opportunity for you because it's a fast-moving market right now for a lot of this green technology opportunity. So what I do, right? I know right now you probably have. I love your approach, very logical, stage gate, but there could be where you can accelerate a little bit in a reasonable way by looking out of a geography.
Yeah. Yeah, I think it's an excellent suggestion, and I agree. So a JV approach, this is actually how SABIC grew historically. I mean, and we can do very similar. We'd basically provide the technology, first develop the plant, own and operate it initially, at least anyway.
Yeah.
The money would come from elsewhere to like fund the whole project.
We can talk offline because if you're interested we're doing this right now, like structure a JV with progressive investment going in, right? So that you're de-risking for both the company and the investors. So I mean, I'd be happy to outside the call, but there's interesting things to be done right now.
Yeah, I think so. One thing I found, and actually David Dupree's presenter, I think, was describing a similar model. So, we're a technology startup, right? So we're seeking funding from, angel investors, VC investors, and so forth, right? none of these guys want to invest in projects. They don't want anything to do with it, right? On the other hand, the people who invest in projects, the infrastructure investors, they don't want anything to do with risky new technologies. So we're kind of
Well,
separating
and
them out.
also, see, they has the exact same problem. Project financing to be worse because of the amount of layer in financing, you need to be at least in the 50 to 100 million. And when you're an early stage,
Yes.
you are maybe looking at 5 to 10 million projects. So there's a disconnect that is very easy, very challenging to bridge there. I agree.
That, I think we're okay. I don't know. We had a couple of conversations with infrastructure investors. So you're right. They
Yeah.
are looking for more $100 million projects plus, and ours are more like 20 million, okay? But if you go with one project, yeah, sure, they'll laugh at you. They're not interested. But if you say, okay, we've got this one project, plus we've got a pipeline of, another 10, 20 projects down the road, then they start to get interested, right? So that's how we're going to be approaching.
We see, I think we have a similar experience in
Yeah.
the conversation that we had, yeah.
Okay.
It was a
Thank you.
pleasure. Great product, great presentation, Dan. Thank you.
Yeah.
Thank you so
Okay,
much,
cool.
Hélène. Thank you, Dan, for the pitch. Yes, there's no time, unfortunately, for the Anne-Marie's feedback. Maybe you can connect with her after the call. Congratulations. Thank you.
Yeah.
Okay, we will now move to the third company, which is Mountain Renewable Energy, presented by Derek. So Derek, whenever you're ready, you can share your screen. Derek, I think maybe you're on mute.
I was just unmuting myself. Sorry.
Yeah, great. Hi.
Hi. How's visibility?
Yes, perfect.
Okay, fantastic. Well, good evening, everyone. I guess it's what, 7 o'clock Central European time?
Yes, exactly. 7 p.m.
All right. 11
And for
a.m.
you?
here.
11
For
a.m.
me, 11 a.m. So I'm Derek Roy. I'm the founder of Chief Mountain Renewable Energy. I think this is probably a non-contentious statement I'm going to make. I think we are in the midst of a historic and consequential transition in global energy demand and availability as we migrate towards a renewable and a sustainable future. This transition has exposed a critical vulnerability, of course, as we move from load-based fossil fuels to more and more intermittent solar and wind. We face the new crisis of intermittency. Currently, we possess a grid that produces energy for which we lack robust and scalable storage and demands energy that we cannot provide for a variety of reasons. Here in the United States, of course, everyone's fixated on the AI issues and data center issues. How do we build resilience into an increasingly renewable future reality? That is the question. The answer is it's not just more storage, it's the right storage. To survive this transition, we must move past the 4-hour limitations of current market leaders in energy storage and embrace a long duration resilience that can bridge the gaps of days and not just hours. Today, I'm going to show you how Chief Mountain Renewable Energy is providing that missing link. Our modular energy storage system doesn't just provide 3 or 4 hours of backup, it provides 3 times that or even more. And while conventional chemistry batteries, lithium X, as I like to call it, polymer, ion, sulfur, die after 5 to 10,000 cycles, our technology is rated for 40,000 cycles. We are currently in the engineering phase of our 2 kilowatt, 25 kilowatt hour manufacturing prototype. By Q1 of 2027, this unit will be on the floor of our lab. This milestone is our value inflection point. It will prove our proprietary integration of electrolyzers, gas storage, and fuel cells work at scale. It will help de-risk for current and future investors. that technology before we move to our first utility scale prototype. The global market is massive, with over $137 billion in estimated energy storage market demands today, growing to $262 billion by 2034. We see the beachhead that we can attack here in the United States, but also globally, initially as being an energy as a service model attached primarily to either refurbished installs or new installs, partnering with the 4 largest solar companies here in the United States. Our roadmap is aggressive but calculated. We are simultaneously moving along with a $4 million federal government track with the Army and the United States Air Force, but our commercial pivot is the real story, we think. Our competition is well established and robust, but conventional chemistry battery focused. They lack duration and they lack life cycles. We anticipate, I put out a 2 kilowatt, 25 kilowatt hour device, but that can grow, of course, if the customer wanted to add additional hydrogen gas storage. And as mentioned previously, our device is rated for up to 40,000 cycles. This is our team. Myself, I have a career in technology sales. Mike Moran is our Chief Financial Officer. He is the yin to my yang. I look at the world in far too optimistic ways. He looks in the world in a much more skeptical way. Ramanagaswaran is a double master's in mechanical engineering and material science from the University of Utah. Pat Allred is handling our electrical engineering. He built custom pumps for the oil fields out here in the Uinta Basin for Shell for a number of years. I think our board of directors is incredibly supportive and also very, very experienced. Mike Assam, I like to refer to him as an organizational development ninja. Prior to his engagement with Exxon, they experienced a number of workplace deaths. He worked with Exxon from the lowest levels of the organization up to the boardroom and implemented a brand new workplace safety protocol and culture. And after that protocol was in place, they went 3 successive years without a workplace fatality. He's an active board member of FinCom, which is the bulb on top of Jets Worldwide that provides global internet access, and they're growing like gangbusters right now. Bruce Kaiser is a mathematics PhD and nuclear engineering PhD with experience with all of the big nuclear companies here in the United States, and built weapons at Hanford Lab for a number of years. Max Stitzer is helping us with our government projects, and he's a retired brigadier general with the United States Air Force. We're projecting revenue growth from our prototype phase to $46 million by 2028, scaling to $340 million by 2030. We're executing this through, as I mentioned previously, an energy as a service model that makes renewable energy storage a predictable monthly operating expense for residences, farms, ranches, small businesses, and then scaling to utilities rather than just a single massive capital hurdle. We are seeking $2.5 million in funding in our seed round to staff key roles, finalize the 25 kilowatt hour manufacturing prototype, secure our next phase lab and development space, and of course, raise subsequent required capital. We anticipate the next round to be at least $8 million to get us to the manufacturing prototype to market by the spring of 2028. This is about sustainable energy resilience for homes, communities, and the global community. I'm Derek Roy, and let's talk about how we can collaborate to make this happen. Thank you very much.
Oh, sorry, I was on mute. Thank you so much for your presentation, Derek. We will now move to Q&A, and we will start with Anne-Marie.
Thanks, Mathilde. Derek, thank you for the walkthrough. I just had a really basic question in terms of like your customer base, because like energy as a service tends to, and the modeling behind it tends to rely very heavily on offtake creditworthiness and contract duration specifically. So can you just like talk us through like some of your target anchor customers, some of the, like, and what their credit profile, how long the contracts are going to be, and what would be needed to justify the asset base overall?
Part of this, I think, is related to my background in sales. Rather than relying on others to sell our product for us, we're going to sell it ourselves. We are going to take a very active role early on, a year, 18 months before we even have a product ready to go, out at high volume events, home and garden shows here in the United States, state fairs. I have a colleague, I know it's completely unrelated, but I think it makes the point that at the Texas State Fair was selling $10,000 and $15,000 mattresses. So obviously those kinds of events have higher demographic prospective customers, which are credit capable. And we will go out and we will take, my notionality today is we will take $1,000 refundable deposit. We're estimating a total value of our solution in today's number of about $20,000. The number I have is $20,250. We will sell it in energy as a service, as you mentioned, leasing type structure, where if they give us $1,000 deposit, it's going to reduce by $2,500 the total, using a leasing phrase, adjusted capital cost. And then we'll have $1,000 installation fee. And taking that out to a 7-year run with, say, a 30% residual, we're looking at a monthly fee, including a monthly program and system maintenance of $250 a month for 7 years. That's the current notionality today.
It's helpful. It wouldn't be a bad thing to kind of speak to in your deck, because I think you are the expert. You can definitely have a very tangible kind of sales approach, and so it would be, I think, something kind of welcome to see in your deck if you're considering kind of updating it going forward. But appreciate the detail, Derek.
Absolutely, excellent suggestion. Thank you, Marie and Anne-Marie.
Thank you, Anne-Marie. Ellen, would you like to go next?
Sure. Nice to meet you, Derek. So,
Very nice to meet
my
you.
background is technology. So, I'm always very intrigued and fascinated in understanding, right, in a pitch, what you say makes total sense. But there's not much information about what makes you different from other like storage solution right now, right? Because this is a pretty crowded space. And so, unless you want to really keep the IP extremely confidential and you just want to kind of like present us with, and then like, discuss it at a later time, could you share with us what's so special about these technologies that you think you can capture the market? Because as I said, it's a pretty crowded space already.
It is I think it's a very crowded space in terms of what I affectionately call conventional chemistry solutions, lithium ion, lithium polymer, etc. I think in the direction that we are trying to go, there is either a lack of focus or a lack of interest. I think some of that is political, for the lack of a better word, but also just related to culture, pop culture. You have gentlemen like Elon Musk who refer to hydrogen as hydrogen fuel cells. And so I think much in the popular culture detracts from a focus on this. To address specifically the technologies, it's It's a holistic approach in which we bind together three core technologies, all of which.
Sorry, go ahead. I apologize.
So we're going to bring together an electrolyzer technology, we're going to bring together a gas storage technology, and we're going to bring together a fuel cell technology. And we are going to bring all three of those technologies together in one device. Initially, our aspirations when we grow up are to be a utility scale provider.
So when you're ready, I would be interested in exploring because I totally believe in what you're doing, right? I think it's not new. We need a lot of new innovation, not necessarily aligned with where the market is going right now. Um, I'm working on a system that's gonna be depending on ocean energy as renewable. It's around desalination. And I think we're looking into potentially it's all about being very creative. That's why I'm asking you. So I would love to explore further outside the call. Is a way we could understanding new technology is not ready now, but as we go through multiple iteration, if there could be a way, right, to associate, if you have like higher performance, to associate that with such a system. So.
Yeah, we think, this is very aspirational. This is a 10-year curve. We think the integration of these technologies will yield green hydrogen at $1.25 a kilogram or less, and energy storage in a utility scale at $75 a kilowatt hour or less. And that's really where the economics begin to change.
That's also if you use solar and wind as a basis, because if you lose ocean energy that has way less intermittency, you can have much better economics. And so that I would be interested in like exploring how it could fit with a system that has way less intermittency. There is still some, right? So you need to de-risk it to see how it could fit.
I'd be excited to participate in the discussion.
Yeah, and I understand it's not ready, but I think, as you say, everything we're doing in terms of hardware has a long-term profile. So yeah, it would be I'd be honored to continue the conversation.
As would I.
Thank you so much, Helen. Now let's ask Claudio if he has some more questions.
Yeah, no, thank you. No, I had the same question because I've seen a lot of different great technologies. So I understand, of course, there is a massive problem with we need energy storage, but I've seen a lot of great technology. So my question was why you? But I think you already answered pretty much. And so I would like to understand your view on the market. So what or the competition in the market. So what will happen in the next 5 years? So how will be the market in the next 5 years? There will be like a consolidations. There will be like other new technologies.
This is my humble opinion after watching the market for basically 7 or 8 years. I think that to the advantage of our company, there will still be an inordinate focus of time, effort, and capital going after what I call conventional chemistry battery solutions.
Mm-hmm.
In my humble opinion, I might be wrong, but I think that's the direction of the market. I think that gives us somewhat of a sleeper advantage. I think that gives us the advantage of lack of focus from the outside. It gives us the advantage with capital to really manifest a solution that meets the parameters and benchmarks that we aspire to meet, and then take the market literally by storm while everyone else is looking the other way, in my humble opinion.
Thank you. Yeah. Thank you.
Thank you, Claudio. Yeah, we have still time
so
for
there was,
one more.
All we need is $2.5 million. And we're going to storm the castle. And they're not even going to see us coming. Because they're looking to the north and we're coming from the south.
Thank you. Laura, would you like to add something?
Yes, I will just do a short follow-up. Thank you, Derek, for the presentation.
Thank you, Laura, for the time.
I am together with Anne-Marie that as a feedback, I would suggest that the presentation needs a little bit touching to have all the insight that you have, because listening to you, Derek, we can see and hear that you're an expert, that you have a lot of data. And it's a little bit of a pity that is not reflected on the presentation, because now today you have the opportunity to share it and talk to us, but normally you just send it over sometimes in a quick, and that's has to be captured there. For instance, on the slide of the competition, also it's a little bit too plain. So as the last question, because it is 1 minute 36 seconds, would be, how does your solution compare in cost to alternatives like batteries that store energy over long periods?
I will try to thank you for the question. I thank you for all your questions. This is the most exciting part for me. So a company like Tesla has a very inelastic go-to-market price point right now, and that has changed relatively little. You may all be familiar with the Hornsdale battery that they got lots of press on 8 or 9 years ago. Wind farm in Hornsdale, Australia, Tesla battery storage, 400 high 400s or low $500 cost per kilowatt hour installed capital cost. Tesla Scatterwash, Arizona, just recently within the last 18 months, $559 million capitalization for that project. It was installed capital cost $548 per kilowatt hour. Those are the hard data that I have. And then I'm from Montana, a very, very recent Berkshire Hathaway Energy project up in Montana, $667 per kilowatt hour. I'm not sure who the battery provider in that one was. So those are our competition on a utility scale. When we get to what our aspirational goal is, our aspirational goal is within 3 years to be at $175 a kilowatt hour, 1/3 the cost, and within 10 years, we aspire to be at $75 a kilowatt hour, which is 1/8 the cost. And we expect, and let me just finish with this last thought. You take a company, space has been in everyone's mindset for the last few days with the mission to the moon. You take a company like ULA, United Launch Alliance, basically $400 to $500 million per launch. Tesla's doing it now for $50 million per launch, let us say. We think those same economics are going to apply. You're going to have incumbent players, Tesla, Sonnen, Base, that continue to have a very, very high cost per kilowatt hour. And if we get our way, we're going to come in with numbers that are 1/3 to 1/10 the price per kilowatt hour.
Okay, looking forward. Thank you.
We look forward to that day too.
Thank you so much, Derek, for the presentation, and all the advisors for the useful feedback. Yes, we will move now to the fourth presenter, which is Flag Turbines, presented by Maarten. And Maarten will share his screen and launch the presentation. Yes?
Can you see my screen now?
Mm-hmm.
So let's see. We pre-recorded the presentation. Sorry. Here it is.
Hello, my name is Maarten van Oeveren. I'm the founder and CEO of the companies related to our blown turbine technology. Blown is an R&D company creating intellectual properties in relation to turbine technology, and its revenue model is based on a fee for licenses and monitoring services. Flag Turbines is a marketing and sales company, and they are responsible for international growth and have commercial profits as a revenue model. And our production company, Blown Products, is taking care of engineering, production and maintenance of the installed base, focusing on efficient production and having a fixed profit per turbine as revenue model. Wind turbines need good wind, and standard turbines get that with high and top heavy structures. Vertical axis turbines are better scalable and therefore easier to produce and to integrate. These turbines receive high mechanical loads on their large and extended blades. So around 100 years ago, French inventor Georges Darrieux, he presented a solution to avoid these loads, but that compromised the scalability advantage. Our blown technology is dealing with these loads, and as a consequence we preserve the scalability advantage of vertical axis wind turbines. This is a 50 kilowatt land model flag turbine installed on the pier of the Monaco Yacht Club with the Mediterranean Sea on the right side. And in 2021 we patented our mechanical solution to absorb high wind load. It's again cylinder technology, but this time the pressure doesn't come from combustion but from wind load. Its low rotational speed gives it a high social acceptance, and with 6 legs we create a self-stable base. Thanks to the very wide direct drive generator we can keep the arms short, and that also results in minimum maintenance. Such a turbine gives always a factor 2 larger rotor surface than for a flat disc of a standard horizontal axis wind turbine. Well, unfortunately the 50 kilowatt turbine doesn't yet exist. We will first focus on the smaller 10 kilowatt land models so that we can gradually increase production systems for larger models. And once we fully understand the behavior of the smaller land models, we can then project that to the more complicated floating models and also to hydro turbines. And once we successfully passed their scale, we then are also ready to develop megawatt scale flag turbines. Well, we intend to license our technology on project basis and to provide engineering services for large scale projects. With ongoing development and investment on energy conversion systems and production capabilities, we boost the adoption rate of our technology. So with the 10 kilowatt land model we compete with the larger and double priced farmyard turbines. Their biggest advantage is the flexible deployment and low regulatory restrictions. 2 other companies are also developing such a turbine, but they follow the Darrieux technology. Agile Wind Power is immediately developing a near megawatt scale turbine, and Jiva Wind offers a much smaller turbine. Well, with our 10 kilowatt turbine we create an initial installed base, and after market adoption we push further with larger scales. And once we have economies of scale, we use that advantage to introduce floating turbines and hydro turbines. We have 17 pilot customers and tested 12 generation turbines with them. In 2025 we ended with a successful test of the 12 generations and all systems worked as expected, and now we are developing a reliable and repetitive production method. Our customers' main motivation to buy was related to their carbon strategy. They want higher energy supply redundancy and see it as a big bonus. The flag turbines are a strong visual showcase of their climate technology leadership. Before founding of Blown, we were colleagues and developed automated production lines and automated trucks. Our commercial team has a career of experience in licensing and team staffing. We also caught attention of Start2S Insights, and they gave us their rising star status as a surprise. We created 2 patent families and are now claiming the patent rights on every continent. And well, with 12 generations of pilot turbines, we developed 95% of the system on our own and have all the production know-how internally. We also developed our remote monitoring and control platforms, and well, they allow us to monitor turbines around the world. We secured 5 subsidy grants and sold to 17 customers with a 90% conversion rate. And even after selling to these customers, we received many more inquiries. But we didn't want to overload ourselves with pilot customers. We are frequently covered in the media, received letters of intent of strategic launching customers. We found a distribution partner in the UK and also collaborate with several skilled partners in the Netherlands. The obtainable market for land models has a value of 30 million, and at this point we keep the 90 billion market for floating wind in the UK beyond scope. We expect that we can target a market share of it in 27. To service the obtainable market, we asked for a new convertible loan of 500,000 euros with a reduction of 10% on the share price, which we plan, where we plan emission in mid-27. These investments will enable us to ramp up the production rate to 5 turbines per week in 26 and to a targeted 20 turbines per week by the end of 27. Eric and I started to work together on this project in 2018 as colleagues then, and when Rob joined, we also introduced controllable and sensors in the system, which really boosted our R&D. Rob and I have both an aviator background. I'm as a glider pilot, Rob for motorplanes. In 23, I encountered with Stefan, a Scotsman living near Glasgow, and he introduced Andy, and together we founded Turbines UK as a local entity to serve the UK market. Andras is collaborating as a member of our launching customer, an energy cooperation, Tooley Solar. It's a local energy community. This is the advisory board. Gust was CEO of a medtech company and advises us on innovation planning for businesses. Brian is a Scottish strategy advisor with a very strong network in Scottish institutes such as Offshore Renewable Energy Catapult and Strathclyde University. He was introduced by Andy. Ian is a retired investment banker and guides us on a conversation with investors. And we are always looking forward to add visionary and impact-minded persons to the board, which is of course also an invitation to an eventual investor who watched this pitch.
Okay, yes, that was a presentation. Happy to
Thank you so
answer
much.
questions.
Yes, let's move to Q&A. Let's start with Anne-Marie.
Sure. Thank you so much for walking through that, Maarten. Really appreciate it. I sort of had a question that started reviewing your pitch deck, actually, and then sort of like was expanded with you presenting. Your pitch references, diverse energy needs and across a number of communities and businesses. And then you reference 17 customers today. Can you kind of like walk us through where specifically you think your beachhead customer is and what that segment is, and maybe speak a little bit to the unit economics that would look like for like a single 10 to 50 kilowatt installation at like the target price point, just so we have a better idea of that? That'd be helpful.
Yeah, so that customer is ideally having a farm and living on a remote location. And apart from farms, we also have fire lighthouses in mind on small islands. So we really target a remote area with an abundance of renewable energy, but bad power grids.
Am I allowed to ask a follow-up question on another topic, or will I be booed out of the room, Mathilde?
It's okay. It's okay. Because Ellen had to leave now, so we have a little bit
Oh,
more
great.
time.
I get Helen's spot.
Yeah.
Great. I mean, I just need a little bit of help in this sector. Maybe you can help me with this, Maarten. Is like vertical axis kind of wind turbines have a bit of a funny history, right? They have a history of underperforming horizontal axis turbines on capacity, is my understanding, and and maintenance cost. So can you help me understand, like, what is the data that the performance data that supports that you have from deployed units, and how would you address that credibility gap? Because sitting in Copenhagen, in the day-to-day, that's often something that I hear being discussed in this sector.
Yeah, well, I love to have this discussion with the scientists who really advocate for continuation with horizontal axis wind turbines. So the big deal with vertical axis wind turbines, as Dario presented, had to have high speed and low torque, is that they are not self-starting. So our data really shows that we are starting up from 1.5 meters per second, which is very low wind, and we can immediately generate power from that. There's no other technology who can propose or show that. And then secondly, we have a power curve, which is also unique. So it's not just a technology, but we can substantiate it with data.
Great. Again, I think just as feedback, Laura has opened this up now, is like, I think I might speak to that a little bit in your deck, because for the people who are either really initiated in this sector or the people who are picking up for the first time, it might be a good way to sort of like introduce, that credibility point and speak to that data. But overall, really great presentation. So thank you, Maarten.
Yeah, thank you for the questions, and yeah.
Thank you so much, Anne-Marie. Let's ask for Claudio's feedback now.
Yeah. So you mentioned, I think, in the presentation, JV Wind.
Yes, the Italian company, yes.
Yes, it's an Italian company, and actually we invested in JV
Okay.
Wind a little bit. So I want to ask you why you're better than them.
So a GY wind is actuating its blades on the hub, and this hub is connected the shaft of the blade where it's pivoting around. And if you introduce a torque on an arm, that torque needs counteraction. So the actuation force to change the blade position is braking, is decelerating, is counterproductive to the generated torque. That's one thing. And secondly, their blades are what we call in the vertical axis wind turbine, we call them razor blades, and that's typical for the Dario technology. Small blades at high speed, and with minimum load. If you then extract a little bit of power, then the system gets distracted, and you have a set point, and on that set point there is immediately a change in the curve. So that, in combination with the counterproductive actuation torque to pivot the blades, is really creating a very messy control of the turbine. Not said that. So you see that the very wide generator in our system is really the heart of the technology. It allows us to produce massive torques, and also to dissipate that torque to a counteracting structure. If you centralize all the generated torques, then you really create a very, very big twist in this central shaft. So imagine the turbine on my back. If it wouldn't have these 6 legs, but just one shaft to the ground, we had it in the beginning, then that there's a lot of twisting forces on that shaft, resulting in high deformation. And secondly, with a central shaft, you will have low voltage output, which is also another consideration that George Darrier highlighted in his patent.
Okay, thank you.
Thank you so much. Yeah. Thank you, Claudio. And now, yes, Laura.
Thank you. So again, I have to do a follow-up on Anne-Marie, because she was into the area of where was my question going. And so first of all, regarding the presentation, it's well done, but I need a little bit more feedback of what is you ask, like the basics of because you mentioned you have a lot of pilots, that is very solid. So it's like you are already there. Like I don't see like a TRL 89 there showing. So kind of like a simple 2 lines point. Okay, we are here, we want that. And that's because you already have a lot of traction, right? So then that would be more like you have a feedback already from the pilots. You have 17, so maybe you have a good feedback from the customers. You can already input it there. And the last question would be, what is the main barriers a customer has to adopt your technology? Like, is it the cost, the regulation? And that would be for me, my end.
So, to understand your question well, the main consideration for someone to buy our turbine, is it correct?
Yeah, so then they have hesitation, as Claudia was mentioning already. There is other competitors that are already there on the market. So then, what it would be, you already explained very well, like the differentiation. But what do you think that is the barrier for a customer? Like, it's a difficult question, to be honest.
Yeah. So when we look at the first competitor right now, it's the standard horizontal axis farmyard turbine. And this turbine is again top heavy with a high structure, so very unstable, and it needs a permanent foundation. So where we aim for is that farmers can put our turbine in the middle of the open field during the winter season when the sun is low and the wind is high, and well, they have to install quite a long cable to the first power connection or immediately hook it up to an electrolyzer or batteries. But that cable is still way shorter than a cable towards the middle of the North Sea. And so we can generate flexible turbines, which can be positioned or ideally on open spots where they can receive perfect wind.
So, but the question is more like, what do you feel as the feedback that there is a hesitation? Like sometimes you have an approach for a customer, and then there is a barrier that you understand, like the blocking area. Like when you have to analyze
so
your
we have to keep customers out. So there is a massive demand, and if we open up for sales, then we have more demand than we can fulfill. Is that answering your question?
Yes. Okay. So then you do not have that case. So it's like completely the opposite. Then I see. So it's fine. So yeah, thank you very much for the presentation and the feedback.
Yeah. So for this year, to start this production, we need the financial model that I just showed requires 24 turbine in the next 12 months. That's 2 per month. And well, we are looking together with Yes Electrical, our distribution partner in the UK. We are looking for 16 pilot customers for these 10 kilowatt turbines and 8 in the Netherlands. And of these 8, there is 1 very firm and 3 others are close to securing. So we need 4 more, and we can be very selective on that. So
Okay.
it's 24. It's just that we need investments in production capability. We cannot not give a firm delivery date right now. We cannot order the components that we need. There are some tooling costs needed. We roughly 100,000 euros in tooling costs that we need to make, and we need to make the generator in the middle. It's currently 60 centimeter. We need to make that double size.
Mhm. Thank you.
Thank you so much,
Yeah.
Laura. Yes, so yeah, Ellen had to leave, unfortunately, but I will ask her to give you like a feedback by email, or maybe you can go on one-to-one after the call. I will follow up on that. So thank you again for
Okay.
presenting, Maarten.
Yeah, it was my pleasure.
Thank you. Yes, we have one more presenter tonight, and it's Enviro Farm. And I will now share the video pitch.
Welcome. I am William.
You don't see my screen anymore, right?
No.
No. Okay, let me do it again.
Now you have it.
Yeah.
And just click on the speaker in front of the
Founder and CEO of Enviro Farm Systems. As a serial entrepreneur with over 50 years experience, I have been involved in multiple business startups. Our current cheese dairy project is shovel ready with site selection, geotech analysis, building permits, layout designs, and environmental approvals in hand. Qualified contractors are identified and ready to bid. Enviro Farm's proprietary green technology, the Enviro Circulator, provides USDA-proven aerobic, nutrient waste, and water bioremediation for reuse and recycling. As with many green tech innovations, aerobic bioremediation does not fit well into existing agri-food production. To fix this, Enviro Farm chose to redesign existing agri-food production systems in ways that provide better green tech benefits and better business results, including increased profits, reduced risk, increased yields, and lower costs. Before we proceed, we need to answer one key question. Why are we here? Most of us are not aware that modern agri-food production is collapsing. Degraded topsoil offers less and less nutrient-dense food year after year. As a result, farm fields can no longer provide food as health. The low nutrient density in food we buy today contributes to epidemic obesity and diabetes. The methane from food production contributes to climate change, while ammonia emissions create significant public health problems, including childhood asthma, elder emphysema, and cancer, adding an estimated $270 billion per year in U.S. public health costs. Enviro Farm's aerobic production systems offer effective solutions to all of these problems, even while producing more nutrient-dense food at lower cost for consumers and with higher profits for producers. Here are the steps in how it works. In step 1, nutrient waste is automatically washed from the barn every hour, leaving floors spotless and odor-free while providing earth temperature cooling surfaces for cow comfort. At step 2, nutrient wastewater is sent to storage basins where it is transformed into safe, odor and pathogen-free 99% true liquid fertilizer. At step 3, whenever plants need food and water, fertilizer is pumped from storage. At step 4, liquid fertilizer is sprinkled directly onto growing crops in precise quantities required. Step 5 simply shows reclaimed safe water being recycled for barn cleaning. Specialty cheese production was chosen as our first project due to sustained 5 to 10% growth over the past 20 to 30 years. Specialty cheeses began trending higher as consumers looked for convenient, tasty food with better nutrient density. Just 2 years ago, the term car cheese, meaning cheese to be eaten as a snack in the car, came to the fore when mentioned on TikTok and Instagram. Consumer cheese demand suddenly surged again. In addition to the founder, the Enviro Farm startup team includes managers with extensive experience in each separate area of agri-food production and operations. Each team member has over 20 years of independent business experience, and team members have now worked with each other on this project for over 5 years. Team resumes are available on our website at enviro.farm. The current Enviro Farm cheese dairy cap stack, totaling 153 million, can be initiated by as little as 2.5 million in pre-seed round. This is followed by a 15 million Enviro bond available from the state of South Dakota and a 10 million community development bond running parallel with a full 25 million seed round. Bonds and seed rounds are followed by 100 million from private loans to reach the total 153 million projected cost. This is offset by an estimated 30% internal rate of return, producing a projected cumulative EBITDA of 160.5 million by the end of year 6. Deeper participation by interested investor lenders can be discussed. Let me sum up with answers to several obvious questions. There is an urgent need to address agri-food's role in climate change, consumer health, producer profitability, agri-food sustainability, and the regenerative soil crisis. Investors and industry are looking for real change. Enviro Farm provides that. The current project solves all the fundamental industry problems facing new production and taps into surging demand for nutrient-dense specialty cheese. Our first site has been named in South Dakota, and a seasoned project team with deep industry knowledge has been assembled. Multiple additional sites are planned as soon as this one is underway. Allow me to leave this final slide on the screen as we conclude. Please note the last item on this list may be new to you. At the request of previous interested parties, we retained a top qualified CPA firm in the agri-food dairy industry to conduct due diligence regarding our business plan. Their conclusion was a surprising 90% likelihood of success. Not something one hears every day from a CPA firm. Their 45-page report is available on request. Thank you for your interest and attention in our project. I can take your questions and comments now, please.
Okay. Yes.
And I'm here for the questions and comments.
Yes, it's Michael will respond to the questions.
Yeah.
So, Claudio, would you like to start?
Yeah, just understanding what is the core innovation here.
What is the what? Excuse me?
The core innovation. So it's just like a
What differentiates us?
Yeah, what is the innovation?
What differentiates us is that this is a new application of proven technology. I'm the only one in this whole call that can't spell technology. So what I'm going to do is talk about the finance and the money and the profitability. This is a highly profitable operation with a very, very low risk. 92 to 93% of the use of proceeds is going directly to hard assets, buildings, land, and cattle. And it's hard assets is the majority of that. We're getting the cap structure is that with as little as 2.5 million, we can get 25 million, a $15 million bond and $10 million bond from South Dakota. We're already registered for Reg A and Reg D with the Securities and Exchange Commission and are looking for 25 million of Reg A. I have secured 100 million on a 2/3, 1/3 basis, so that if we can get the 50 million in deferred debt for the bonds and the equity from Reg A and Reg D, we already have, and they've already spoken with Bill. My contacts from New York will put up $100 million in debt in a patchwork form of so much in mortgage, so much in leases, so much in asset-based lending, so much in senior debt, and the program works out very, very nicely. So we already have the majority of funding kind of committed, contingently committed upon the ability to get 25 million, which we can get with as little as 2.5 million, although it'd be nicer to have the 25. So that's what differentiates us is, just like Dave said earlier in the first presentation, the largest feedstock cost is transportation. When you're sending milk to a cheese dairy, you have the transportation of the milk in tankers or pipe, or whatever way they're doing it. Here we're putting the cheese manufacturing facility right on the dairy site. It's a circular operation with our complete control. We're using the aerobically treated, not anaerobically, but aerobically treated manure. And the technology is all explained in a 2-minute video on the website on how that works. And we treat the land around us and the crops. We're using AI to apply the fertilizer without buying fertilizer. This is produced fertilizer right on the farm. We're using AI to apply it at the right time. Sometimes people will put manure on early on and then just let it go. The plants have a specific time when they need growth fertilizer. It regenerates the land. It increases productivity. It's cheaper than store-bought fertilizer. And again, it's AI generated. The plant tells us there are sensors there, all of which are included, and doing it at a much cheaper price and much more organically than buying bags or other types of nitrates, which is an incomplete fertilizer. The aerobically treated manure is a complete fertilizer with a lot of micronutrients as well to increase the nutrient value of the food. That's what differentiates us. We have top cheese people. We can use the milk for anything. We picked out the specialty cheese because it's the most profitable, and the market is secure. The total amount that Enviro Farm would be making doesn't even cover the expansion of the marketplace every year. So it was a highly profitable operation, well thought out and well ready to go.
Thank you.
Thank you. Anne-Marie, would you like to go next?
I'd love to, and then I'd love to see if Laura will then follow up with me, because I have a follow-up on Claudio's question, which is, when I was reviewing your deck before, I had this question: is like, is this a big cheese solution? Is this a big dairy solution? Like, what part of the market and why are they kind of addressing this? And then as you were talking, as we were kind of going through the pitch today, Michael, I kept having that question because there's like a wrapper of land regeneration in a lot of what your materials are saying, but then your pitch very much focuses on big dairy and big cheese. And I understand the profit margin point. That makes a total sense. A lot of sense. I think I would like frame that from the get-go, if that's what you
Great,
mean.
great. What
And
we're doing is that fertilizer, the real technology that we're bringing to this is going out for crop production. And the crop production, either we will own the land or it'll be adjacent to the cheese dairy operation, and the farmers will be able to get the fertilizer directly from pivots that we're going to install for them. We will install the pivots. It'll come directly from the lagoon, which is a romantic word for but they'll get the fertilizer directly from there. It will increase their productivity, increase the nutrient value, and be less expensive for them. So it's a circular operation. The animal feed is a big part of it. And thank you for asking that question, if that wasn't clear. And that's how it comes about. The actual technology is going back, which is the aerobically treated manure, which causes it not to smell, and takes away all the liability of adjacent places that complain about things like that. There isn't any. It takes away all the emissions, zero ammonia, all those things are addressed at a cheaper price.
I would go with that. I know you had the recording, but Michael, I think you can sell this much like a lot better, and you're doing so really convincingly. I see Laura also agreeing with me in a way, because one of my questions as you were going through the deck was playing was like, what is the primary revenue, right? And what is that mechanism today? And how dependent is it on farmers or voluntary carbon market pricing or it improving? Like there were just so many questions, and I think you're so much more convincing. So if I can applaud you for that, but also try and convince you to be your own best kind of pitcher in a way.
Thank you. I'll ask for a raise.
Please do. I'm happy to support it.
Thank you very much.
Thank you, Anne-Marie. Laura.
Thank you very much. So yes, I totally follow on Amory. I think we need a connection tonight. Very nice to meet you, by the way. Thank you, Michael. And I totally agree that it's more convincing your pitch. So I would like to follow up on the cheese because you chose it as the project to see how it's working, because indeed the milk, you could choose another product. Have you, in terms of marketing, have you investigated, are you going to put the product as a premium to, identify and to
Yes,
compete
we
with the
have.
other standards? Is it like, what about the taste? Is it different as well? Like there is a lot of
It's going to be customized for the particular grocery chain in certain cases, and even for the specialty charcuterie board producers at holiday periods and holiday time, what they want. So we go to a particular grocery store, we will make a custom cheese, guarantee that no one else will have that formula. We have the flexibility to do that. And we will have a cheese that will be not only just private labeled, but it's not going to be the same as anybody else's. And it will be made to their taste that they want. We also have gone to a Houston, Texas company that will package and do internet sales for us should we decide to go that way. And we're looking at that seriously. We're also looking at in the United States, I'm sorry, I'm not familiar with some of the European places, but there's something called David and David. There's something called nuts.com, which are huge holiday packagers of specialty nuts, of dried fruits, of specialty cheeses, and we will be making those specifically for them. In the interim, we can get into the high-end cheese right now that are French cave made cheese and with the same quality that they have, and even run it with a French cave at a significantly lower price because of the basic way we're doing it. So thank you for the question. The answer is it's going to be a specific customized application for them. There's a big kosher market. Are the people in New York that are looking at doing the debt, 100 million in debt, have asked us if we would do a huge kosher and use their distributors for it. I said, absolutely. We even have plans for the rabbi residence on the facility.
Yeah, I think it's a good approach. I would recommend you to look first locally and then not so much into the internet sales to see how it goes. Of course, you can see the develop since you can
Thank you
also
very
try a
much.
different project.
Thank you for that. Thank you. Good.
Okay, thank you, Laura. Thank you. Yes, this was congratulations on the pitch, Michael, and this was the final presenter tonight. So I want to thank everyone
Thank you
for
very much.
joining and for presenting, and the advisors for the feedback and the questions. And so we'll be sharing the contact details to everyone, like the list and the recording we upload on YouTube, and then we share it to everyone. Hope you enjoyed the evening.
Thank you, Mathilde. Thank you.
Yeah,
And another
thank you
nice
so much.
job. You did another nice job. Thank you.
Thank you so much. And yes,
Thank
I
you.
hope to see you at some other events. It was a pleasure. Okay.
Thank you.
Awesome. Well
Thank you very
done.
much.
Thanks, Mathilde.
Bye-bye.
Great to
Thank
meet
you.
you.
Very much.
Have a good
Have a nice
Bye.
evening.
Thank
evening.
you.
Bye.
Goodbye.
Bye.
Bye.